So the LeetCode question to discuss today is question number 2342. Max sum of a pair. Max sum of a pair with equal sum of digits, which statement is we will be given a zero indexed array nums consisting of positive integers. We can choose two indices I and j such that I is not equal to j and the sum of digit of the number nums I and the sum of digit of the number nums j must be equal. We need to return the maximum value of nums I plus nums j that we can obtain by following the above mentioned condition, that is I must not be equal to j and the sum of digits of the nums I must be equal to sum of digits of nums j. If no such pair were found, we have to simply return -1. To solve this question, I initially came up with a very naive approach, that was to use an unordered map which will having key and int as an int comma int, key and value as int comma int, such that the key part will be having a number which we would found after obtaining the sum of digits of a particular number, and we will be storing that number, the number given in nums, in our value part of the key having the sum of digits. I first defined sum of digit function SOD, which takes a number n and will return the number and will return the sum of its digits. So the approach was to first iterate through the given array and would first calculate the sum of digit, which is a new number. For later on part, I will be calling this number, the number which we found as the sum of digit, I will be referring sonum, like some num, it kind of related to me, so I put it sonum. So sonum would have the sum of digit of a given number. So come to the algorithm which came to my mind was to iterate through the given number, all the numbers, and first calculate its sonum and then put the number in its value part. And when in later part, if we get the same sum of digit, that is sonum, we will update our value part by that number, and to return the answer we need to find the maximum value part. That approach came to my mind, but there is a flaw in this, like it is very clearly mentioned in the question that we have to find two numbers, but if we follow the algorithm that I have said, it may result that there are 3 or 4 numbers having same sonum, sum of digits. So it may gonna add all of them and things would not go as expected. So that approach failed. So later on I came up with another approach, and that did work. So coming to it, instead of having the value part as a single integer, I will be using value part as a pair of integer and integer, such that the pair part, the respective value part, which is pair now, will have two numbers having same sum of digits. So the algorithm goes like, but before going on, there are a few important variables which will be helpful in determining the maximum value of nums I plus nums j. The first is sj, a variable which will be storing size of the nums vector I is equal to 0 for iterating all over the indexes, and sonum, as I have mentioned, it will be storing the number which we get of finding the sum of digit of a given number. So, and there is another boolean variable, bool flag is equals to false initially. So let's start. We will be using while loop here. While I is less than sz, that is through the end of the given number. First we will calculate the sonum of a given number. Sonum is equal to SOD num. I will be later on, I won't say this way to say code. The code is very much visible in your screen. Sonum is we will be storing the sum of digit in the sonum, and then we will check, does the map has any key value sonum yet? If the map doesn't have the key sonum yet, we will be storing a value at the first part of that sonum. Like in the else part, we can see that in the unordered map UMP, at the key value sonum, at its first part we are storing num_i, and in the second part we are simply storing int mean, because we do know that all the numbers are positive, so any number with positive can fill that place. There is a catch also. If no two number are found to be of the same sum of digits, then the second part will use as an indication that it doesn't have any pair, so we can skip that part while calculating the maximum. So we have discussed the else part. Now come the if part. If the sonum key is already present in the unordered map which we have created, then we will check, is the number at ith index is greater than the first part or not. If it's greater than the first part, then we will put the first part in the second part and will update the first part to the number, and that in this way we will be having the top two largest number having same sum of digits. Else if the number is not greater than or equal to the first part, we will try to check, is it greater than second or not. Is it found to be greater than the second number, we would update that. And if any of the time it happened that the sum of digit is found to be present, we will turn the flag to true. So in this way, for each of the sum of digit, we will be having its top two numbers. So basically the main part has ended. In later part we can see that if the flag is false, which means there isn't any two number having same sum of digits, so it would be simple to return -1. And the second part is int. We are creating a max. Mx is equals to int mean, so that we can find the largest sum value. So we will iterate through the unordered map and would first check if the second of the second, which means the second part of the value is if equal to int min, we simply have to skip it. But if it is not int min, that it indicates that it must have two numbers, first and second. So we will store the sum of first and second numbers in s, and we will compare it with mx variable. If the sum s is found to be greater than mx, we would update mx to sum s, and with this we will be eventually having the maximum value of num_i plus num_j at mx, and we simply have to return from there. So this was the approach, and it is an efficient one, though it's not the best, but it is a solution that get accepted and that came to my mind. if I would get any optimized solution for this question, I will simply do that and would